We present the automatic control system designed for dosing of chemical reagents in the industrial water treatment technology. In this part of the video, we demonstrate the hardware operation of the Schneider Electric M340, which functions as a master controller of the system. We start on the auto mode screen of the HMI. On the stand, we press auto button and the auto mode activates and the pump 1 turns on automatically. Next, on the HMI, we select manual mode and the screen change. Then on the stand, we press the manual button and the manual mode indicator lights up. On the HMI, we activate valve 2. When valve 2 opens, the controller automatically turns on pump 1, showing the logical link between them. Finally, we press valve 4 on the stand, which uses it to return the sodium chloride solution back into the mixer. As a software part for the M340, you can see the system running in automatic mode exactly as it does in the hardware demonstration. When we press auto mode, the controller automatically activates valve 1, valve 2, valve 3, valve 5, and the pump 1. The entire process starts without any manual actions. Next, on the main screen, we switch on manual mode. Here, valve 1 is activated automatically because it supplies the main pipeline, and this ensures that the main flow path is always ready before manual control begins. When we manually turn on valve 2, the system automatically opens valve 3, following programmed logic. At the same time, pump 1 is also triggered automatically because the dosing pump is controlled on the slave controller M241. When we manually activate valve 5 and since the pressure is within the safe range, the flow continues normally. If it is needed, we can also manually open valve 4, which allows us to redirect the sodium hypochlorite flow back into the mixer. In this section, we show the hardware realization on M241, which operates as a slave controller. Here we have the main control object, dosing pump 1, and the M241 is responsible for calculating and monitoring its safe operation based on pressure. Since the pressure transmitter is connected to the controller, the video begins with an alarm. Because of the pressure is outside of the allowed range, the system requires the pressure to stay between 2 and 23 bar, and any deviation immediately triggers an alarm. As you can see, we then activate valve 1, which sends an electrical signal to pump 1. If the pump runs properly and the pressure returns to the normal range, valve 2 opens and allowing sodium hypochlorite solution to move to the next stage of the process. And the additional information, we scale the pressure signal so that 0.1 bar from the transmitter corresponding to 1 bar in the system, allowing for easier interpretation and control. In the software part for the M241, the visualization reflects at the same logic that we demonstrated in the hardware section. Here you can see how the system responds to the pressure change, how pump 1 is enabled through valve 1, and how valve 2 opens only when the pump is running correctly and the pressure is in the safe range. The visualization clearly shows how the controller manages the process. It continuously tracks the pressure value and displays alarms and system states in real time, making it easy to monitor the entire operation. In addition to this, we integrated a PID controller into the M241. The PID loop now regulates the system based on the input signals from the pressure transmitter, ensuring smoother control and automatically maintaining a required operating range.